All right. Let's do these examples together, shall we? Okay. What do you think of the first one? This one looks just like the one about the popcorn. It takes 1.5 hours for Tim to mow the lawn. Linda can mow the same lawn in 2 hours. How long will it take John and Linda working together to mow the lawn? So, basically, Tim works at a rate of T over 1.5. Linda works at a rate of T over 2, and those two together would finish one job if you added those rates together. So let's see, what would I have to, what's the common denominator of 1.5 and 2? Smaller. Yeah. Skip count by 1.5s. Oh, I'm sorry. Yeah, you're right. It is 6. What am I thinking? Sorry. 6. Yeah, it is 6. So we're going to times by, let's see, what times is this one to make 6? This would be, so I guess we'll just times by 6 on this side, times by 6 here, times by 6 there. So that would be 1.5 goes into 6, 1.5, 3, so 4 times. 2 goes into 6 3 times. And I now have 7t is equal to 6. So from there, t is equal to 6/7 of an hour. Now, nobody in their right mind says, hey, how long is that going to take? 6/7 of an hour. So we obviously would rather have that answer in minutes. So that's 6/7 of 60 minutes, which,
It's not any prettier.
That's not good. Well, it's a little prettier. Let's see. I would use my calculator to get a decimal for that and then just say how many minutes it is. I don't think I'd bother with seconds. So 6 times 60 divided by 7. So 51. It actually is closer. It's 51.4. So I would round that to 51.5 minutes. Therefore, they could mow the lawn together in 51.5 minutes. So there we go. Problem number 2. It takes 6 hours for pump A used alone to fill a tank of water. Pump B used alone takes 8 hours to fill. We want to use 3 pumps, A, B, and C, to fill the tank in 2 hours. What should the rate of pump C be, and how long would it take pump C to working alone to fill the tank? You know, this is actually a bad question. It's not even grammatically correct, so I'm not going to worry about that. That's the one. That's the question we want to answer right there. How long would it take pump C used alone to fill the tank? So we're going to do that. So we already know that they're going to fill in 2 hours, right? So we are going to try to figure this out, again, the same way. We know that pump A, in terms of hours per rate, is 2 out of 6. Pump B, in terms of hours worked per rate that it works, is 2 out of 8. Pump C is 2 over I don't know. So that's my variable. I guess I should define my variable. Let x equal rate C fills the tank. And then together, that would fill one tank. Because I know the time this time. Notice in the last example, I had to use the variable on top because I honestly didn't know what time it was going to take for them all working together to work. This time I do know that it's 2, right? So all of these are actually time over rate at which they work.
But isn't that the total time it should take though?
But it's the same time for all of them, right? 2 hours and the job is done for all of them. That's why we were able to use the same t for the numerator and the other ones. But in this one, the variable's down here. Okay, we could simplify this a bit. That's 1/3 plus 1/4 plus 2 over, I don't know, is equal to 1. What's the common denominator of that? 12, not quite 12, 12x. So if I times this one by 12x, I'm going to get 4x. If I times this one by 12x, I'm going to get 3x. And if I times this one by 12x, I'm going to get 24. And 1 times 12x is 12x, right? LCD is 12x, if you need me to write that down for you. So I am going to get 24 is equal to 12 minus 7, which is 5x. And 24 divided by 5 is 4. Oh, hang on. 4.8. Oh, I'll stick to fractions. 4 4/5 hours, because that's, again, an easy fraction to turn into minutes, right? 4/5 of an hour, which in minutes is 60. 5 goes into 60 12 times. So therefore, I like this answer better. 4 hours and 48 minutes. And we're done. I guess I should put it therefore. I did put it therefore.
Add a sentence.
Yeah, I should put a sentence. Therefore, therefore, all 3 pumps. Oh, no, that's not what I want. That's right. C can fill the tank alone in 4 hours, 48 minutes. There we go.
What was like the empty equation we had? Like it was like hours per rate, or like?
Yeah, it's basically, okay, it's basically time per rate at which you work.
That's not confusing.
I don't think so. All right, moving along. I will let you guys now try problems 3 and 4, because they're just like problems 1, 2. Actually, problem 3 has a little bit of a twist to it. I like problem 3. I'll let you guys think about that one. So problems 3 and 4, we'll let you try on your own. Let's do one more car one together, and then the other worksheet I handed you has all kinds of car ones. Okay? Actually, you know what? I'm looking at this one. I don't know if I like this one better or not. Let's see. You can do that one. That one's just like the first one. This one's a little different. Okay. At 5 a.m., Mr. Johnson leaves town, traveling at 120 kilometers per hour. At 7:30 a.m., Mr. Spray leaves the same town, traveling at 150 kilometers an hour. At what time will Mr. S overtake Mr. J? That means they'll catch up and meet at the same place.
Oh, no.
So, Mr. J and Mr. S. No, not 2 equations, 2 unknowns. This is all 1 equation. So this time we know speed. I guess I could say velocity, right? V. This time we know speed. Mr. J is going 120 kilometers an hour. Mr. S is going 150. Distance, okay, let's remember how the formula works, right? Velocity equals distance divided by time. So distance is the one I actually don't know here. That's speed times time. I actually do know what time is. Time would be, well, let's say it takes Mr. S X amount of time. It would take Mr. J X plus 2.5. Why the 2.5? Because of these 2 numbers here. Now, why did you add the 2.5 to Mr. J? He's the one that started earlier. Because to make these 2 numbers equal to each other, you'd have to add the 2.5 to the person who started out earlier. You could do it as a subtract if you wanted to, but I like this one. You could do it, you could put minus 2.5 down there if you'd rather. So here we go. There is the time, and of course, distance is speed times time. So this is 120 times x plus 2.5, and this is 150 times x. So there we go. What do we know about these two distances? They're the same, right? That's what overtake means. It means that they're at the same place at the same time. So the distance for Mr. J equals the distance for Mr. S. Right?
Where's the fraction?
This one doesn't turn out to be fractional. I was going to say unfortunately, but actually fortunately, this one's easier. So 120x, 2.5 120s is, I want to say it's 300. Am I right about that?
Yeah.
Yep, 300. And equals 150x. And if I minus 120 from both sides, I get 300 equals 30x. So x is 10. Now, what is that? Again, always ask yourself, what did they want me to do? They wanted me to actually find out how far away and at what time. So two things I'm looking for. What time and how far away are they when that happens? So time, we actually already know now. Time is 10 hours, but when I say at what time, you can't say 10 hours. You have to refer to a clock. That 10 hours would be 10 plus when Mr. S started. So Mr. S started at 7:30, so this would be 7:30 plus 10 hours, right? So that would be, you could say 1730 hours if you want to be military time,
Why when he started?
but you could also call that 5:30 p.m. Now the other part of the answer is, of course, the D. So take the 10, put it into the easier of the two, which would be, I guess, this one. So D would be 150 times 10, which is 1,500. So I think I'm ready for a conclusion statement. Therefore, at 5:30 p.m., Mr. S overtakes Mr. J 1,500 kilometers from town. There we go. So now you can try the other ones yourself. So okay, I'm going to stop my little video right there.